Good morning, students. Students, this lesson is of class 8 for the subject of physics, topic formation of images in spherical mirrors and the characteristics of image formed, which is covered in chapter 7, reflection of light, starting on page number 160 of your physics textbook titled Concise Physics by Selena Publications. Students, kindly take a scale, eraser, and a sharpened pencil as you all have to make ray diagrams along with me. Students, before starting the ray diagram, there are 4 rules. That is, there are 4 rays which we can take for making ray diagrams. Out of these 4, any 2 of the rays can be taken as convenient incident rays. So the 4 rules are, first of all, if a ray is passing through center of curvature, which is denoted by capital C. Second, a ray is passing through focal point, that is capital F. Thirdly, a ray parallel to the principal axis. And the fourth rule is a ray incident at point P, where P stands for pole of the spherical mirror. Now students, for clarification of the diagrams, see figure number 1 and figure 2 drawn on page number 1 of the notes sent to you on 7th December 2020. So student, for the first rule, that is a ray passing through center of curvature. When a ray is incident, and passing through the point center of curvature, and when the incident light strikes the spherical surface of the mirror, then the incident ray gets reflected in the same direction, that is the same path where incident ray was traveling. So students, if a ray is passing through center of curvature, it will strike the reflecting surface of mirror and it will get reflected in the same direction. So this is our first rule. Students, now I will first discuss the third rule in the same diagram shown in figure 1. Here, when a ray is taken parallel to the principal axis, the incident ray is parallel to the principal axis. So students, what happens when it strikes the mirror? If a ray which is parallel to the incident ray is parallel to the principal axis, then after striking the mirror, it gets reflected such that it passes through focus point after getting reflected. So the ray parallel to principal axis will strike the mirror and the reflected ray will pass through focus point. So till now what we have discussed? A ray going parallel to the principal axis will get reflected and will pass through focus point. And if a ray is going through center of curvature after getting reflected also moves back in the same direction. So students, make sure that you are understanding the position of the arrows here. So the incident ray arrow is pointing towards the mirror, and for the reflected ray, the arrow is pointing away from the mirror. So students, after doing the first two ray diagrams, now let us study the ray diagram for second and fourth part. Now the second part was a ray which is passing through focal point. Now see figure number 2. When a ray is passing through focus, the incident ray is passing through focus. It strikes the mirror and it gets reflected, and the reflected ray is parallel to the principal axis. So if a light is passing through focus, if a light is incident and passing through focus, it gets reflected in such a manner that reflected ray is parallel to the principal axis. And the fourth last rule was, if a ray strikes the pole, after striking the pole, the light will get reflected from the pole such that angle of incidence will be equal to angle of reflection. Students, in any case of reflection, angle I is always equal to angle R. And this fourth diagram, the fourth rule, we are usually not taking due to the complexity of angle formation. So we can take any two rays out of all the four, and mostly we take first and third ray for making a ray diagram. Now, students, before starting the ray diagram, remember one more thing, that focus will be always drawn at a distance half of the radius of curvature. That is, distance between P and F should be equal to half of the distance between P and C. So students, now let us learn formation of image in case of a concave mirror. So the formation of image in case of concave mirror, students, the first case is when object is placed beyond center of curvature. Beyond center of curvature means the object is placed farther away from center of curvature and also away from the mirror. So students, here in this case, the object is shown with the arrowhead, and now let us see how to draw the diagram. My first ray is a ray going from the mirror, going from the object to the mirror, and this ray is parallel to principal axis. So when a light is incident parallel to principal axis, it gets reflected and will pass through focus. This was our third rule, which we have drawn in figure 1 also. So a ray parallel to the principal axis after striking the mirror goes away from the mirror and it passes through focus point. So this ray which is passing through focus point is known as reflected ray. While students, the second ray which I'll take is a ray passing from center of curvature and striking the mirror. Now what will happen? After striking the mirror, the ray will retrieve back its direction. It will retrace its path backward. So, if a ray is going through center of curvature, after striking the mirror, the reflected ray is also coming back in the same direction. Now, students, see a point where the two reflected rays meet. The reflected ray passing through focus and the reflected ray passing through center of curvature. So these two rays meet at a point, and the point where the ray intersects each other, you will form an image at that point. So students, now while drawing the image, what we will do? We will put the arrow at the intersection point. This is an image. Now see students, when we consider the object, see the object, the arrow of the object is pointing upward. While in case of image, the arrow of the image is pointing downward. So students, this kind of image is known as an inverted image. The image is an inverted image. And students, remember always that in case of the image, if it is inverted, it is always known as real image, as we have done in first exercise of this chapter. An inverted image is always a real image. And students, see the size of the object and size of the image. Are the two sizes equal? The object, the height of the object and height of the image, are they equal? No, the image is smaller in size. So we say that image formed is diminished or smaller in size as compared to that of object. So students, these 3 points are known as characteristics of the image formed. That is, what kind of image is formed? So image formed is real, it is inverted, and it is a diminished image when the object is placed beyond center of curvature. Now students, coming to the second point, here the object is placed at focus point. Now students, see the ray diagram drawn in case B on page number 2 of the notes provided to you on 7th December 2020. So students, the object is placed at focus, that is on the point of focus. Now, first of all, we will take a ray parallel to the principal axis. After striking the mirror, the light will get reflected and will pass through focus. While in case of the other point, I'll take a ray which is passing through center of curvature. Students, you have to draw a ray diagram. Here what I have done is I have taken a top of the object and the center of curvature. Just join the 2 points. And if you join the 2 points and strike it on the mirror, so this is the ray which is passing through center of curvature, and after striking the mirror, it reflects back in the same direction. Now students, if you see the diagram, the two reflected rays, are they intersecting at any point? No, they are not intersecting. These kind of rays which do not meet ever are known as parallel lines. And students, in such a case, we say that the object, when placed at focus, forms an image at a very farther away point. And such a point is known as infinity. So the image formed is at infinity, and the characteristics of the image is it is real, inverted, highly magnified. Highly magnified means it is very enlarged and it is formed at infinity. Now continuing further, we will discuss what happens if the object is placed between pole and focus. So now in case C shown in figure number C, page number 2 of the notes sent to you on 7th December 2020, students, now the object is placed between pole and focus. So let us continue with the ray diagram. The rules are the same here. The ray parallel to principal axis, the ray parallel to principal axis after striking the mirror reflects and passes through focus. So if the ray is incident parallel to the principal axis, after getting reflection, it passes through the focus point. While the second ray is the ray passing from center of curvature. So if the ray is passing from center of curvature, then it strikes the mirror and gets reflected in the same path. So students, the two reflected rays are not meeting in front of mirror. And kindly see the diagram drawn in case C. These two rays, reflected rays, they are not parallel either. Why they are not parallel? Because the distance between the two is continuously increasing. The distance between the two rays are not same. Rather, it is increasing. Such rays where the distance increases are known as, we have already done, what are they known as? They are known as diverging rays. So diverging rays otherwise do not meet. But students, if I produce these diverging rays backward, so if I produce back, how to produce it back? You only have to take a scale and produce it back without bending or moving the scale. So if you produce the rays backward, then you can see a point where the two reflected rays, they are not actually meeting though. Actually, so they were moving away from each other. But it appears that they are meeting behind the mirror. They are appearing behind the mirror. And students, whenever you are drawing a ray diagram behind any kind of mirror, whether it is a convex mirror or a concave mirror or a plane mirror also, we have discussed it in plane mirrors, you always have to draw a dotted line behind the plane, behind the mirrors. So there is a point where your reflected rays are appearing to meet. And see, the point is not downward, it is upward. So the arrow of the image will also be upward. Students, now if the object was lying in an upward direction, then the image formed is also in, the arrow is shown in an upward direction. Since the intersection is occurring at the upward direction. So students, whenever you are having the arrow of the image at the same point as the arrow of the object, this kind of image is known as that it is an upright image. It is known as upright. And there is one more very common word used, that is the image formed is erect. So students, if the image is erect, it is always virtual, always. Okay, so the image is erect, it is virtual, and see the size. The height of the image is more than the height of the object. So we say that image formed is magnified. It is not highly magnified as it was in case B. Rather, it is just magnified. So students, virtual image is always drawn dotted. See the mirror, the image drawn behind the mirror, I have drawn it dotted. So this is a rule also, that virtual image is always shown dotted, while a real image is always shown with a solid line as shown in case A. Since the image was real, it is shown with a solid line, while in case of virtual image, it is shown in dotted form. So students, if image is formed behind the mirror, it is always virtual and erect, while if the image is formed in front of the mirror, it is real and inverted. So students, now you can pause this interactive session and kindly draw the diagram for the formation of image when the object is placed at center of curvature. That I have not drawn. The object has to be placed at center of curvature. One ray diagram for this category, and the second, draw it when the object is placed between center of curvature and focus. That is, the object is placed between C and F. So students, kindly draw the two ray diagrams, and after you have drawn the ray diagrams, you can resume this session further to check your ray diagrams.